It's recording. Algebra 2. We're on lesson 6-6. Solve exponential equations. Today's date is Wednesday, December 9th, 12. I want to use blue though. 12/9, 2020. I always say the year now because it's a cool little time capsule to say, oh yeah, that was way back in 2020. It's 2030 right now. Look at how I looked when I was 10 years younger. The objective today is to do what? With the quiet raise hand. No one wants to read the objective? Go for it, Wyatt.
Use properties of exponents to solve exponential equations.
Yes, we can finally do it, guys. We can actually solve it. We can actually use the tools that I've been teaching over the past week to actually do a problem now. All right, here's the strat. If the exponential is equal to 1, the power must be what? Because you know that anything to the power of, dang it, is equal to 1. Everyone has this, right? Right, Andres?
If the exponential equals 1, the power must be 0.
Yes,
Right?
exactly. Must be 0. So anything to the power of 0 is equal to 1. Perfect.
Yes, sir.
The other part of the strat is just get both of the bases the same on the lower left and the lower right. So once your bases are equal, then the powers must also be equal. And I remember last year, people really struggled with this statement. But if I have, 2 to the power of x, and that's equal to 2 to the power of 2, the only thing that x can be is the 2 over here. If this was a 3, then x has to be a 3 because these sides are equal to each other. The only way for that to work is if the exponents are the same. So first, make sure your bases are the same. And then once that happens, ignore them. Just look at the powers, set them equal to one another. Let's try an example. Example number 1. Solve this exponential equation for x, and it looks hard. But you know a lot of rules and tricks to try to solve this problem right now. Because anything, I don't care what number it is over here. That base could have been, a googolplex minus, not infinity, but it doesn't matter what happens because anything to the power of blank is equal to 1. What does this exponent really equal? We know that this 3x minus 2 is equal to a certain number because anything for the base to the power of something is equal to 1. What did I just say? Like one of the strats. Charles?
Anything to the power of 0 is 1.
Yeah, so this 3x minus 2 must be 0. That's the only way that I can get to 1. So that's our first step. We say 3x minus 2 is equal to 0, and we have regressed all the way back to unit 3 in Algebra 1. We know how to solve a linear equation. Who can do that for us really quickly? Prove to me that I passed you in Algebra 1. Jose?
So would this be when you add 2 on both sides, right?
Yep, so you get 3x is equal to positive 2. I'm not going to show work because you guys are massive with this now. And then do what to both sides?
And divide by 3.
And you get x is equal to
2/3.
2/3. And if you are at the level where this is so easy, you can do this in your sleep, you can just see this and jump to the answer, and I'm okay with that. If people get lost though, we will slow down. When I see that blue 3x minus 2, I immediately think, oh, 2/3, and I'm done. You can even start skipping these steps now too, because we're just so good at solving linear equations. And there's the answer, x is 2/3. We're on to the next problem. All right, example number 2, solve the exponential equation for x. Okay, it's a little bit harder. Nothing is equal to 1 because those are the easiest types of problems. Now I have a base of 3 and a base of 27. Those bases are not the same. We need to get them the same. Again, there's 2 strats. One is if anything is equal to 1, then set the power equal to 0. The other one is make sure that the bases are equal. The bases are not equal, so set them equal. How are we going to do that, Wyatt?
Well, 27 is the same thing as 3 cubed. So
yeah, so let's go ahead and say that's 3 cubed. Nice, and that's still to the power of 7/3. And what's going to happen with these powers up here, Wyatt?
You're going to multiply them together, which what would that be? That'd be 21/3.
Ooh, yes, and then there's a shortcut. You don't have to multiply them together. You could instead.
I don't know.
cross cancel. Chunk, chunk.
Yeah.
But I agree. If I come over here and do some scratch work, I can say 3 times 7/3 is the same thing as 3/1 times 7/3. Multiply the tops, well, I got 21. Multiply the bottoms, well, I got 3. And then that reduces 21 divided by 3 is just 7. Again, the shortcut is just cross cancel and you would have gotten 7. So our next step down here is going to be 3 to the power of 4x plus 5. Look at this. I haven't touched that left-hand side. The right-hand side now is 3 to the power of 7. I'll pause here because I've been going kind of fast. If you have the ability to turn your camera on, Jade has already talked to me. If you have the ability to turn your camera on, please do it. I would like to see your face. What do I do now? If there's no questions. If you don't know, I can scroll up here and let you look at the strat. Get the base, the same base on the left and the right. We did that. So this piece right here, give ourselves a giant check, and then we're on to the next piece. Since the bases are equal, the powers must be equal. What does that mean? What do I do? I will cold call on someone. This is an easy step. You should know this. Well, I don't want to make you feel bad if you don't know this now by saying that, so I shouldn't have said that, but you guys got this. Like that, this last piece, that's what we're working on. Jenny.
Wait, what was the question?
What are we doing now? So we're at this step, 3 to the power of 4x plus 5 is equal to 3 to the power of 7. The bases are the same. Since the bases are equal, the powers must be equal. What is my new equation from here? How do I say the powers are equal as an equation? Don't overthink it. It's pretty straightforward.
My brain is not working right now.
So how do I say 4x plus 5 is the same thing as 7? I basically regurgitate what I just said, but change is into something else. 4x plus 5 is 7. I'll even write this piece for you. 4x plus 5 is 7. What do I put in here? How do I make this an equation? Every equation needs this certain sign.
Is it equal?
It is indeed equal to, yeah.
Oh, okay.
Thank you. I just want to make sure that everyone can follow this. Since the bases are the same, these exponents must be set equal to one another. That is our general strategy here. And then we solve. So again, if you can just solve this immediately in your head and pump out an answer, that's awesome. If you want to just do it step by step, that's also fine. Let's give this to someone new. I'm just going to start cold calling on people to get you guys in here. Cohen, you're up. Solve this. You have 4x plus 5 is equal to 7. What do we do?
Subtract 7 from both sides.
That might,
Or subtract 5 from both sides.
5 would be better. So if you subtract 5,
Yeah.
4x is equal to what?
2.
2. And then finally,
Divide 4 from both sides.
you get x is equal to,
2/4.
which is reduced to,
It's 1/2.
there it is. And box it. X is a half. Thank you, Cohen. Give me a fist of 5 on these first 2 examples. How well do you follow me? The first one was the first trick, setting the exponent to 0. The second one was the second trick, just make sure the same bases and then set the exponents equal to each other. Sergio's at a 4, Wyatt's at a 5, Andres is 5, Jose 4, Charles 4, Cohen 4, Jade, Jenny, Josie, Fern. What are we at? 3 for Jenny, 4 for Jenny, Fern 4, Jade 4, Josie.
But I have a question.
Oh yeah, go for it.
So in the step that's written in black, I'm just confused on the math there. Why did you... Oh, did you subtract 5 from both sides?
To get from the black to the next orange step?
Yeah.
Yes, a co and subtract 5.
Oh, okay. That makes so much sense. Okay, thank you.
Yeah, thanks for making sure you understand. I appreciate it. And Josie, she said she's at a 3. Thank you. So we're on to example number 3, which is very similar to example 2, just slightly harder. Let's go ahead and zoom in here. Shrink. All right, I need to get the same base on the left and the right since I don't have anything equal to 1. Again, if it was just equal to 1, that's a super easy problem, but it's not. So I need to make this thing equal to just 7. How? Use your rules of exponents, your properties of exponents. Or even better yet, what is 49? 49 can be written as 7 to some power, right? This is a gimme. I'm going to get someone new. 7 to what power is 49? You got this, Fern.
7 to the power 2.
Yeah, so let's go ahead and rewrite that as 1 over, I want to save some room here, 1 over 7 to the power of 2. That is really what's inside the parentheses. This is still to the power of 2 minus x. Left-hand side hasn't changed. I'll be rewriting this bit, 7 to the power of the 3x minus 1. I should rewrite it correctly. Okay, I want to get this as a non-fraction. How can I use properties of exponents to make that into, I'll probably have to use negative powers, but how am I going to rewrite this as a non-fraction? Charles?
Well, first you would have to distribute the power, I believe.
If you, what do you distribute? Are you distributing the 2 minus x?
Yes.
That,
So,
the path that you're going down is going to be really difficult though. I just want to rewrite just the inside as a non-fraction.
you could have 1 divided by 7 over 2. 7 under 2, sorry.
So 1 divided by 7 over 2 like that?
No. So, just like the, I don't know what it's called, but like the long division symbol, or you could just have a divide symbol. And then on one side is 1, and then on the other side is 7 squared.
1 divided by, I'm not sure what you're talking about, sorry.
The like divide symbol with like the 2 dots and the line.
1 divided by 7 power 2. I mean, yeah, you're correct. That is an equivalent form, but that doesn't get rid of the fact that it's still being divided by. I want to try to get rid of this division. I want to try to get rid of the fact that it's a fraction right now.
Oh, just subtract the exponents.
Subtract the exponents. What do you mean by that?
So 1 is to the power of 0 and 7 is to the power of 2.
Yeah, so you could subtract them if this was a 7 up here, but because they're different bases, you're not allowed to subtract.
Okay.
But there is a property of exponents that allows you to kind of just flip-flop. You remember the one that says you're allowed to move up as long as you do this special thing?
Oh, if you make it a negative power.
Exactly. So what should I have here?
You should have 7 to the negative second power.
There it is. Yeah, 7 to the negative second power gets rid of my fraction. This is still 2 minus x. Thank you, Charles. And I'm really close. I basically have the same base. The problem is I still need to get this top right piece simplified. Yeah, what?
You're going to want to multiply the -2 times 2 minus x.
Perfect. What power is that going to leave us with on the right-hand side over here?
Would that be -4 minus, no, plus 2x?
There it is, -4 plus 2x. Perfect. Now these are as simplified as possible. What is our next step in solving? This is the one that Jenny did for us last time. I've been going back and forth between kind of same people. Jose?
So you would just the powers, right?
Yep, so what should I write out?
So it'd be 3x minus 1 equals -4 plus 2x.
There it is, nice. All right. then someone solve. I haven't heard from Jade in a bit. If I don't think actually at all today. Jade, can you solve this for us?
Okay, so are you gonna add 1 to both sides?
Sure. Yeah. So if we add 1, then you're going to be left with 3x, no more. Your 1 is equal to what on the right hand side?
-3 plus 2x.
All right.
And
Next step.
then subtract 2x from both sides?
Perfect. That's going to give you what on the left hand side?
X.
Boom.
And
There we go.
yeah.
All right, guys, that is the end of the lesson. It's really just these two tricks over and over again in different forms. Tomorrow, we're going to do really the harder version of what we're doing today, where I'm making you, instead of doing like this, I would call this like a maybe 4 or 5 step process. It's going to be a 7 to 10 step process because there's lots and lots of rules of exponents that you'll have to master by tomorrow. Cool. Well, that concludes the lesson. Let's give fist of fives either in the chat or with your cameras. How well can you use properties of exponents to solve exponential equations? So, seeing 4, 5, 4, 4, 4, 4, 4. And then Jade and Josie. Josie's at a 4. Jade's at a 4.5. I just saw it now. Okay, cool. And that concludes our lesson.